have great stories in academia and in automotive, not so much with Dassault. I started my career at Ford for about 10 years, and then I was recruited by industry to develop two design programs at a university, product design, transportation design, and just 2 years ago I joined Dassault. So part of this relationship that Scott is referring to is one of the things that we do. I'm part of the academia group, and my focus is strategic partnerships, is the centers of excellence, which we're working with Scott and the team at OU to basically help establish a center of excellence. So our company, we're now closer to 25,000 employees. We're really a global company, and we're in just about every single industry. A lot of times when I jump into the specific content, unfortunately our company is better known by its products, and you'll see some of those products here shortly. So people have always asked me to give a little bit of background on the company, so I'm just going to run through these slides really quick. If anyone has any questions, let me know. So the headquarters is basically in Paris and Vélizy in France, and the company is really came out of aviation, so you may have heard of Dassault Aviation. So in 1929, when the company was founded, they started in the late 60s, early 70s, started developing their own technology tools with computer-aided design with CAD. And then in 1981, basically Dassault Aviation spun off Dassault Systemes, and since then the company has really grown. And one of the things that we're really well known for is not only our technology in aviation and automobiles, but especially now in virtual twins. So you can see here a lot of these corporations that we've acquired over the years. Many of the companies acquire others with M&A, mergers and acquisitions, for growth. What our company has done is basically done it to execute the virtual twin strategy. So all these companies basically represent a technology that was deemed critical to basically develop virtual twins. So kind of our mission statement is harmonizing product, nature, and life in a sustainable fashion. So you can see here, we're basically 50,000 institutions with a very large footprint in terms of number of students using our technology. Sometimes you might even be using technology and you don't even know that it's part of the suite of technologies that are within Dassault Systemes. So this is an important slide, especially when it comes to semiconductors, because it's not just graduate students and industry, but we're basically developing our technology so it can be used and to be grown, going from basically a technician, and there's another slide actually that talks about it, this one. So this slide, I always would hate to showcase it in an academia setting, but it really speaks to what's happening in semiconductors. I think someone was asking earlier, can I come in and get an intern as a technician? So individuals who sometimes, when I was in academia, a big part of my job was trying to keep students in school because they couldn't afford some of the tuition, they would have to drop out. So what I used to do was try to get them an internship so they would be able to afford the tuition. So that's kind of the equity that our company wants to see with individuals, is to basically empower them through starting off as an operator, moving to a technician, moving into an engineer, and then becoming an entrepreneur. So workforce of the future is one of our major focuses because our customers, one of the things that basically prevents us in terms of growing is that they're always looking for employees that know how to use the technology. So that's one of the reasons that we're basically partnering up, and our group didn't really exist outside of 2 years ago. The academia representative from each of the different brands that we had basically resided within the brands. So these are the brands. So you might be familiar with SolidWorks, CATIA, maybe Simulia, Abacus. So this is just the major brands that we have inside the company. But what you see there in the center is what we refer to as the compass. The compass basically integrates all those brands together. So when you're using the platform, the 3D Experience platform, even though the brands are segregated, they're really all integrated. It's a database. So when you make a change, it's object-based. It basically updates the entire model. So in many of the tools or processes as you guys go into industry, as you move through the process, you're constantly exporting, importing data, sometimes translating it to be able to do your portion of the process. The platform, and this is why many of the companies and even some of the conversations we've had with semiconductor companies and even with Intel, they're really interested in this because it makes the process very, very efficient. So I'm going to just get these slides, but this basically has a summary of the capabilities. And then we go from basically the molecular scale with our Biovia brand, where it's material as well as pharmacology discovery of drugs, all the way to the macro scale of doing virtual twins of cities, architecture, and everything in between in terms of automobiles, products, life sciences, infrastructure. So every product that you can possibly imagine that could be manufactured, usually about 90% of the products that exist out there has used at least one of our technologies. So I'm going to just skip over this. So we're basically multi-physics, multi-domain, just as I was explaining in terms of the scaling. And we have a virtual human, a virtual twin of a human that's FDA, and we actually have symposiums. So that same technology, why that's important, gets basically fed into this ecosystem with virtual twin strategy for semiconductors. So we don't necessarily have every single solution to the process. This is where the partnerships with many of the companies come in play. So we're basically the architect, the architecture. Think of us as an architecture where if we don't have a capability, we partner up with some of the other companies. I'll use Lam as an example, Lam Research, or it could be even some of our other competitors that some of our own customers might be using. They can actually plug into the platform because of the virtual twin capability, which allows.
Just behind you there may be cables in case you touch them.
Okay.
Oh, is it turned on?
What happened?
Yeah. Yeah.
Oh.
I think the cables got a little stressed out. That's all.
Why is it showing yours though? It's on us.
Oh, it's switched back to the desktop. I think you may put the HDMI back in, pull it off, and put it back in.
There you go. Touch it. So we're just getting to this.
Okay.
All right,
Yeah,
cool.
right. Okay.
All right. So there's three quick little videos I'm going to show you. The first one kind of gives the summary of this partnership that we're started with Purdue, but really we're looking to do more with Ohio University as well as the consortium that's here in the state. So I'm going to just play this just as an
The
example.
video we are about to see will introduce you to our recent Purdue University and Dassault Systemes partnership to create a new platform for advanced semiconductor collaboration between government, academia, and industry. We will see several use cases, but there are many that have yet to be addressed. Here we are seeing the transition from the physical lab to the virtual lab and are focusing on our K-Bay. Facility managers can use our Fab Virtual Twin to optimize the layout of our equipment. The immersive, photorealistic virtual twin will help our new students understand the clean room environment. Sustainability is an important topic for us at Purdue, and we will use the simulation capabilities of the virtual twin to reduce our carbon footprint and improve our quality. Particle simulations are one example of how we can reduce power consumption while ensuring we maintain our cleanroom ISO standards. In this example, we are measuring particle dispersion, comparing half mass versus full mass airflow rates.
So would you be walking around?
Student training and workforce development are also
you
important
could be,
topics we address with
but
our
we
virtual
haven't
twin
felt it
strategy.
that far.
We are now seeing a brief VR training on our Plasmatherm tool. This type of virtual experience can accelerate our students' learning curve and expose them to the most advanced equipment available. The images we are seeing are not just renderings, but are physics-based models that mimic the physical world. Our foundry and equipment partners can also benefit from these models when they design their fabs and optimize their production processes. The tool we are viewing now demonstrates the capability to perform kinematic simulations to better understand equipment operations. Process engineers can also benefit from the multi-scale, multi-domain simulation capabilities available with this technology. Materials characterization is another area where we can benefit with robust, atomic-level virtual twin simulations. Physics-based virtual twins enable next-level immersive training, infrastructure sustainability, and collaborative R&D. We welcome your input and participation as we continue on this important visualization journey.
So one of the reasons the virtual twin of Purdue's lab was created is, the workforce that's needed, there just isn't enough space to provide for researchers. So developing a virtual twin of that, even for training, because right now they have a bottleneck of how many individuals they can basically train, as well as be able to do a lot of the simulation before before you send over using the shuttle program, right? It would be great if you actually did some of the simulation, some of the testing beforehand, and to basically quantify that your design actually has met a certain standard, so that when you go and fabricate it, your chances of it actually performing increases. So we started doing, taking basically a PDF of the CAD drawings and creating three-dimensional models of the lab. And when we started doing the airflow simulation, part of Purdue's challenge is that even though they have students and researchers go through a clean room gowning process, a lot of the students don't take it very seriously regarding like hairspray, makeup, all of that basically can come off of you and it'll contaminate the room. So they wanted to show students that this is why it's important. So I'm gonna run through, so this next video, I might be able to actually talk through it. It runs through really quickly. So this is going to show you a couple of snapshots of the last video, but it's going to go into more of the VR experience that you'll be able to see. So some of this recording here in a couple of minutes comes directly from the Apple Vision Pro. as it would be doing a demo than just showing you the video. And this last one, I'm not going to show the whole video, but we're actually in the process of presenting this to Purdue in terms of certification for our clean room. So they have their training process, so this is just showing you, this is exactly what you would see if you were there at the facility, and then we could do a similar thing here at OU. And I'm just going to speed this up here really. Bar. But anyways, you'll see here that you'll see a video. So they do have, part of the training is testing what you could take into the room, what you can't, and then being familiar with the layout, where everything is supposed to be located. So that's part of the training that they go through. And then there are some videos, so we embedded the videos into the VR training that basically Purdue wants, and then you'll get certified. So this is very similar to what you would experience, maybe a slightly different process if you were working for Intel or another company that has a clean room. And I think all the manufacturers are basically trying to move away from having people inside the clean room. They want to eliminate the human factor, but for R&D, that's still going to be something that's going to be a little bit challenging. So that's just a quick glimpse. And the last thing I'll end here, and I was apologizing to Scott, I didn't get a chance to bring this. So we developed a semiconductor game. So it has a board and cards. So I guess the next ASCENT, yeah, exactly. I'll have to bring maybe one for each of your consortium schools.
Yeah, that'd be great.
And then you guys will have to give me feedback on it. So this was actually developed, and it was developed internally, and then they had a bunch of different groups. We're not looking to commercialize it, we're just giving them out as gifts for some of our partner companies, but it was more for students, so we're going to be giving them out to you and the team. So
Can we get two?
absolutely, absolutely. I have a whole
I'll
box
definitely
that
like
was
to
shipped
use
from
one of
Europe.
my demos, yeah.
Yeah, so next time you guys have your ASCENT meeting, it's an enticement. You would like one? Absolutely. So I was really bummed out because I have a whole box sitting in my dining room, and I purposely didn't put it away so that I'd be staring at it to take it with me, and somehow I blanked out. So I'll make sure that you guys get one. So I'm going to be next door with the Apple Vision Pro. So if anyone would like to see it, the one thing that I'll note is if you wear glasses, you can't fit the glasses in the Vision Pro. So if you're wearing contacts, perfect. If you don't have good eyesight, people do struggle with it. So unless you have a good vision, but you're welcome to come over, and I'll have an iPad that'll connect to a projector so you can experience what someone else going through it.
And if you haven't used the Vision Pro, there is a 5-minute setup process for each
Yes.
person to go through. So it uses eye tracking, so you have to go through, Keith will take you step by step through that, but just be prepared that it takes 5 minutes for you to get ready before you actually can be immersed. So.
And I think most of you are going to fly through it, especially individuals that have some experience with gaming. They go through it like super fast.
It's a really interesting interface.
It's really good.
Yeah. Thank you, Keith.
Yeah, you're
By the way,
welcome.
thank you.